Since the dawn of civilization, humanity has gazed at the stars and asked one haunting question: are we truly alone in this universe? Billions of blazing suns stretch across our galaxy, each one potentially harboring alien worlds bursting with life. Yet every time we scan the night sky for signals, we are met with nothing but silence. Which raises a terrifying possibility: is life incredibly rare, or are we simply not looking hard enough? There's a stunning collision of ideas that seems almost impossible to resolve. On one side, we are physically insignificant, tiny specks on a pale blue dot lost in an infinite cosmos. Yet on the other side, there's a breathtaking argument that we may actually be extraordinarily valuable. Because when you crunch the numbers, the average number of advanced civilizations in a galaxy like ours could be as low as 1, or possibly even less. Our galaxy, the Milky Way, holds somewhere between 100 and 400 billion stars, with at least as many planets orbiting them. A groundbreaking study suggests up to 60 billion of those planets may sit inside habitable zones, regions where the conditions for life could actually exist. For life as we know it to emerge, a planet needs liquid water, energy, and nutrients. These ingredients appear surprisingly common across the cosmos. And yet, we have found no one. So, where is everybody? This is the heart of the Fermi Paradox, named after the brilliant physicist Enrico Fermi. The question is devastatingly simple: where are they? Consider this. There are between 200 and 400 billion suns in the Milky Way alone. Most likely harbor planets. Many of those planets could be Earth-like. We're talking 13 billion years of cosmic time, hundreds of billions of suns, and potentially trillions of worlds. So why hasn't a single civilization risen before us, say a billion years ahead, and spread its existence across the entire sky? Why has no one escaped their home world and left a mark we could detect? Why is the universe so eerily, disturbingly quiet? One powerful explanation involves self-replicating machines, so-called von Neumann probes, named after the legendary mathematician John von Neumann. The concept cuts right to the core of what life actually is. What is a human being, after all? At its most fundamental level, a replicator. Here's what's truly mind-blowing. This is a physical object, operating under the laws of physics. And we replicate. So there's absolutely no reason we couldn't build replicators that are essentially AI-controlled. Imagine a 3D printer with mining capabilities fused together. You launch it toward the asteroids, toward Mars, toward Alpha Centauri, and all the raw materials are already waiting there, allowing it to replicate itself endlessly. Scientists have actually modeled how these replicators might spread across an entire galaxy. The math is staggering. Given reasonable future technology, accounting for travel time between star systems and replication speed, the calculations show that if anyone had launched even one of these machines just a few 100 million years ago, they would already be everywhere. It spreads like a virus. Exponential growth. The entire galaxy colonized. And yet, we've seen nothing. No signal. No machine. No trace. You could argue that's proof nobody ever tried. Or, and this is where it gets chilling, maybe these replicators are the size of a smartphone. Maybe they're microscopic. Maybe they're already inside our solar system, and we simply don't recognize them. This is the heart of the Fermi Paradox, the haunting observation that across all of human history, across every telescope and every scan of the sky, we have never once detected evidence of another civilization. And that is deeply strange because there has been so much time, so many planets, so many opportunities for someone to do something visible. And as far as we can tell, silence. One of the most disturbing possible explanations is that advanced civilizations simply don't last long enough to be detected. They flicker into existence and then vanish, destroyed by their own technology, or wiped out by cosmic catastrophe. If intelligent civilizations routinely burn themselves out before reaching the stars, then the chances of two civilizations existing at the same moment become vanishingly small. Carl Sagan himself warned that civilizations may not survive the very stage we're in right now, the industrialization era, before interstellar travel becomes possible. Because when a species industrializes, it faces challenges that may be universal, written into the laws of physics itself. The strain on a planet's climate, the poisoning of the atmosphere, and perhaps most terrifyingly, the development of nuclear weapons. At some point, any civilization advancing toward the stars will inevitably unlock nuclear physics, and with it, the terrifying power to destroy itself. Just 100 years ago, that kind of total self-destruction was impossible. Now, we could choose to end everything. It may be that these challenges are simply too dangerous to navigate, not quite a law of nature, but a brutal law of civilizations. Perhaps they just cannot survive the forces unleashed by industrialization and nuclear science. And here's the chilling part, we haven't passed that test yet. There's actually a name for this phenomenon. It's called the Great Filter. The question is haunting. Where exactly does that filter sit? If it's already behind us, if the hardest hurdle was something like the leap from single-celled life to complex multicellular organisms, which does appear extraordinarily rare on Earth, then we can breathe easy. We made it through. Microbes might fill the universe, but nothing more. But what if the filter lies ahead? What if the danger zone is right now, this precise moment when a civilization gains the power to reshape its planet or annihilate itself through war? We could be approaching that wall, and we might not break through it. That terrifying possibility would also perfectly explain the Fermi Paradox, the deafening silence of the cosmos. Many people believe the paradox needs no explanation at all, convinced that alien beings have already walked among us. But in science, extraordinary claims demand extraordinary evidence. One fascinating alternative idea is the zoo hypothesis, the unsettling suggestion that advanced extraterrestrial civilizations do exist, but deliberately choose to leave us alone, watching silently, much like zookeepers observing animals from behind the glass. It's theoretically possible, except for one glaring problem: real zookeepers don't hide from the animals. So if cosmic observers truly exist, they are extraordinarily skilled at concealment. As detection technology grows more powerful and sophisticated by the year, any civilization avoiding our gaze would need to constantly and perfectly outpace our abilities. That's an almost incomprehensible level of coordination. Recent estimates using the Drake equation paint a startling picture. The Milky Way may host only a tiny handful of detectable civilizations, possibly just one: us. Earlier, far more optimistic calculations have been revised downward, now accounting for the brutal reality that civilizations may simply burn out before ever reaching the stars. How many worlds in the Milky Way harbor life? How many intelligent species have risen and fallen in this galaxy alone? The honest answer is devastating in its simplicity: we don't know. We only know of one world with life right now. Most would instinctively guess that surely, somewhere even within our own solar system, something else must be alive. But we have no proof of that yet. What we can say with confidence is this: we must behave as though we are the only civilization in the Milky Way. That has to be how we manage our world, plan our future, and protect what we have. Not because it's certainly true, but because right now we have virtually no data telling us otherwise. Ultimately, the Great Filter hypothesis should serve as a powerful wake-up call for all of humanity. It reminds us that if detectable civilizations are truly rare, perhaps because so many destroy themselves before reaching advanced spacefaring stages, then we must be absolutely vigilant in protecting our own survival. If we are alone in the Milky Way, our failure to overcome our greatest challenges could extinguish the flame of consciousness in our galaxy forever. Carl Sagan once argued that if a civilization like ours becomes truly spacefaring, multiplanetary, and then interstellar, it must have already solved the deep problems that make us violent and predatory. He suggested that as you grow more powerful and navigate these extraordinary challenges, these filters that may lie ahead, you are forced to evolve beyond your darkest instincts. To flourish and reach the stars, a civilization must first learn to live together as one, unified on a single planet. Sagan believed that advanced civilizations would have conquered these problems long ago, And so we should not expect the kind of violent, conquering species so popular in science fiction films, because civilizations consumed by violence simply cannot build the technology needed for interstellar travel. Whether he was right or being optimistic, we simply cannot know. The true power of the Fermi Paradox is that it is anything but dogmatic. It asks an open, haunting question. Given that we have not yet detected anyone out there, what could possibly explain that silence? It does not claim there is nobody. It observes that we see no one right now and asks, why? Perhaps every civilization hides. Or perhaps, given everything we know about the history of life on Earth, complex living things are simply extraordinarily rare. We have just arrived at Gliese 667. Brace yourself. Set the drone to survey mode and prepare for full atmospheric analysis. This could genuinely be the moment we finally make contact. It would undoubtedly stand as humanity's greatest discovery in all of history. Imagine civilizations out there, perhaps millions of years ahead of us, wielding technology we can barely conceive, waiting silently in the vast, dark depths of space. And even finding microbial life alone would be absolutely remarkable, proof that life began in more than one place, wherever the right conditions exist. If we discover life on Europa and find that ocean has existed for billions of years with active geology and still find nothing, scientists may begin to wonder whether the origin of life itself is extraordinarily rare. But when most people ask about aliens, they're really asking something far more thrilling. Is there intelligent life out there that we could actually communicate with? That's an entirely different question. Let's imagine we find microbial life on Mars and Europa. The next explosive question becomes, how likely is it that life, once it begins, eventually evolves into intelligence, into civilizations? We don't have a definitive answer, but we do have one staggering clue. On Earth, it took roughly 3.8 billion years, nearly 4 billion years, to go from the first spark of life to a technological civilization. The Earth itself is only 4.5 billion years old. So here's what's mind-blowing. Life appeared almost immediately after Earth formed and cooled down, but then it took nearly the entire age of our planet to produce something like us. That's about 1/3 of the entire age of the universe. If that timeline is typical, and it may well be, then intelligent civilizations could be shockingly rare, even in a galaxy as vast as the Milky Way. And this becomes even more dramatic when you consider just how violent and unforgiving our universe truly is. Most stars don't even survive for 4 billion years. You need a very specific kind of star. The longest-lived stars, red dwarfs, are actually the most common in the galaxy, yet they may be completely hostile to complex life. Their planets must orbit dangerously close just to stay warm enough. These stars are intensely active, bombarding nearby planets with radiation. And those planets become tidally locked, one face permanently scorched in eternal daylight, the other frozen in permanent darkness, just like our moon always shows the same face to Earth. That kind of environment seems deeply unlikely to produce anything resembling a rich, complex ecosystem like ours. Many biologists, when confronted with everything that had to go right, the billions of years, the precise conditions, the staggering chain of unlikely events, conclude that complex multicellular life, and especially intelligence, may be genuinely rare in the cosmos. But this is science. In the absence of hard evidence, we make educated guesses based on what we can observe. And crucially, none of this means we should stop searching. Programs like SETI are actively scanning the skies for radio signals and other signatures of civilizations. And the James Webb Space Telescope is now powerful enough to analyze the chemical composition of alien atmospheres directly. Imagine detecting oxygen flooding an alien atmosphere, a powerful chemical signature screaming that photosynthesis is happening on a distant world. Shockingly, we might discover life orbiting a faraway star even before confirming it exists right next door on Mars. And there's something even wilder to consider: megastructures, Dyson spheres, colossal engineering projects built by unimaginably advanced civilizations, so enormous they'd be visible across the cosmos. Astronomers are actively scanning for exactly these signals right now. But here's the haunting truth. So far, we've found absolutely nothing. When we picture intelligent alien life, we imagine living, breathing creatures, organisms shaped by evolution, not unlike ourselves. But what if the most advanced civilizations have completely abandoned their biological origins? After millions of years of technological progress, perhaps they've transcended flesh entirely, uploading consciousness into machines, becoming permanent digital beings. Such entities wouldn't age, wouldn't tire, and could survive interstellar journeys that would utterly destroy biological life. Could the alien intelligence we're desperately searching for no longer be biological at all, but purely digital? This connects directly to the Fermi Paradox. It seems almost inevitable that a biological civilization like ours will eventually transition into something silicon-based. We're already heading there. And once that happens, suddenly sending life across the stars becomes possible. Von Neumann machines, self-replicating probes spreading endlessly through the galaxy. Consider this: why aren't humans living on Mars right now? Not because we lack capability. We have machines there already, because sending robots is simply easier than sending fragile biological humans. Our bodies weren't built for space. They never evolved for it. Machines, however, are perfect for it. The future of any advanced civilization is almost certainly machine-based. And that raises a terrifying question. If a civilization achieves this, it becomes effectively immortal. Its machines spread across the stars forever. So why hasn't anyone done it already? We live inside a universe of staggering, almost incomprehensible scale, countless galaxies, each containing billions of stars. The idea that we're truly alone feels almost absurd. Yet, across our entire Milky Way, we hear nothing but eerie, deafening silence. Perhaps intelligent civilizations do exist out there, just none close enough for us to ever reach or even detect. The real question isn't whether they exist, but how far away they are, whether they overlap with us in time, and just how vast the distance truly is between us and them. Just imagine this: the laws of physics don't actually forbid traveling between galaxies. Here's how. Special relativity, Einstein's groundbreaking theory, tells us something extraordinary. As you approach the speed of light, distances compress dramatically. Launch from Earth accelerate to roughly 99.99999% the speed of light, and something mind-bending happens. The distance to the Andromeda Galaxy, normally 2.5 million light-years away, shrinks by a factor of 7,000. That's called the gamma factor. Suddenly, that staggering cosmic distance becomes a fraction of what it was. The closer you push toward light speed, the more that factor explodes, growing arbitrarily large. In theory, intergalactic travel within a human lifetime becomes conceivable. But there's a twist. Time itself slows down aboard the spacecraft relative to everyone left behind on Earth. These aren't science fiction ideas, this is standard physics. So while reaching those speeds seems practically impossible with today's technology, the universe's laws don't technically slam the door shut. Now, every single star visible in the night sky is almost certainly orbited by planets, many potentially capable of harboring life. Scientists estimate billions of Earth-like worlds exist in our galaxy alone. And yet, silence. No signals, no visitors, no proof of intelligent life anywhere. Could life truly be that vanishingly rare? Honestly, we don't yet know. But we're actively searching. The James Webb Space Telescope and next-generation instruments may soon detect biosignatures in distant planetary atmospheres. Meanwhile, missions to Mars are investigating whether conditions existed there 4 billion years ago, conditions strikingly similar to those that sparked life on Earth. The Perseverance rover is collecting samples right now, and if the Mars sample return mission succeeds, those samples could reach Earth within the next decade, potentially rewriting everything we know about life in the universe. Scientists now believe there may be shocking evidence that life once existed, or might still exist, on Mars. Ancient oceans, lakes, and rivers likely covered the red planet around 4 billion years ago. Even today, the soil holds surprisingly high water content, and hidden pockets of liquid water may lurk beneath the surface. The question of Martian life remains wide open. Right now, 2 extraordinary missions